The Kepler telescope was built with a single goal, to focus on a specific region of the Milky Way in search of exoplanet. This exoplanet hunter observed hundreds of thousands of stars and discovered thousands of planets beyond our solar system during its mission. Launched in 2009 aboard a Delta II rocket as part of NASA's Discovery program, Kepler's role was to continuously scan a fixed area of the Milky Way to identify planetary systems. At the time, it boasted the largest primary mirror ever sent into space, and was equipped with a 96-megapixel camera to analyze incoming light. Astronomers aimed to determine how many stars had planets orbiting them, and how many of these exoplanets might have conditions suitable for life. Over its 9 years in space, Kepler observed 530,536 stars and confirmed the existence of 2,662 exoplanets. These newly discovered worlds are unlike anything in our solar system. Most are much larger than Earth, orbiting their stars so closely that they complete a full revolution in just a few days. Some planets have extreme environments, with one side so hot it could melt iron and vast oceans of molten rock. Other Jupiter-sized exoplanets orbit to stars, offering a binary sunset view for anyone standing on their surface. Kepler's lasting legacy lies in its discovery of Earth-sized planets orbiting in the habitable or Goldilocks zone, where temperatures are suitable for liquid water essential for life as we know it. While being in this zone doesn't guarantee life, the presence of water is a crucial factor. One of Kepler's most exciting finds is the exoplanet K-18b. In September 2019, two independent research teams reported signs of liquid water in its atmosphere. Located 124 light-years from Earth, K2-18b is about 8 times the mass of Earth and orbits a red dwarf star called K2-18. A red dwarf star is the smallest and coolest type of star, and it's also the most common in the Milky Way. Based on Kepler's data, astronomers estimate that around 6% of red dwarf stars have Earth-sized planets located in the Goldilocks zone, the region where conditions might support liquid water and potentially life. The discovery of water on one such planet is a milestone in the search for habitable alien worlds. K2-18b is the first planet in Kepler's discoveries that has shown signs of water in the habitable zone of its star. Initially found in 2015, K2-18b's composition has since been studied with other telescopes, including Spitzer and Hubble. Kepler mainly used the transit method to detect exoplanet. This method involves measuring the slight dimming of a star's light when a planet passes in front of it. By analyzing how much the light dims and for how long, scientists can estimate the size and orbit of the planet. However, detecting the transit of an exoplanet is incredibly challenging. For instance, Earth's diameter is only about 1/109th that of the Sun, meaning an outside observer would see the Sun's light dim by only 0.008% as Earth passes in front. Kepler's instruments were sensitive enough to detect even these tiny changes in brightness. One of Kepler's earlier breakthroughs came in 2014, when it discovered the potentially habitable planet Kepler 186f, which captured the imaginations of space enthusiasts worldwide. Located 500 light-years away, Kepler 186f may even experience seasons and climate similar to Earth's. A new study from Georgia Tech analyzed the planet's spin and axial tilt, finding that its tilt remains stable like Earth's, suggesting it likely has regular seasons and a stable climate. Similar research is ongoing at universities worldwide, as scientists continue to analyze the massive dataset Kepler has provided. In recent years, several Kepler discoveries that were previously dismissed as potential Earth-sized exoplanet due to algorithmic errors are being reevaluated. These false positives are now being reanalyzed with data from other telescopes. One notable example is Kepler 16409c. In mid-2020, while astronomers were reviewing old Kepler data and comparing it with new findings from the Transiting Exoplanet Survey satellite tests, they confirmed the existence of this exoplanet, which has promising conditions for life. Located 300 light-years away, Kepler 16409c is very similar to Earth in size and estimated temperature. It is just 1.06 times larger than Earth, and the amount of starlight it receives from its host star, a red dwarf, is about 75% of the sunlight Earth gets from the Sun, suggesting a potentially similar surface temperature. Kepler 164 serves as another example of an Earth-sized planet in the habitable zone of a red dwarf star. However, we should be cautious, as only 16 out of the 2,660 exoplanet identified by Kepler are located in the Goldilocks zone, where conditions might support liquid water. Of these 16, some are tidally locked to their parent stars, meaning one side of the planet is always facing the star, which is an ideal for supporting life. Others are more similar to mini Neptunes, with thick hydrogen atmospheres. If this hydrogen layer is too dense, the pressure and temperature beneath would be too high to sustain life as we know it. Additionally, red dwarf stars, despite being cooler, are often more active than stars like our Sun. This means planets orbiting them could be exposed to higher levels of harmful ultraviolet radiation. Surface temperatures on these worlds can range from 100F to 116F, making them either colder than Antarctica or hotter than Earth's most extreme deserts. While current technology doesn't yet allow us to fully analyze the atmospheres and compositions of these distant worlds, there is still hope. Based on Kepler's data, astronomers now estimate that 1 in 5 Sun-like stars hosts an Earth-sized planet with temperatures that could support life. Since about 20% of the stars in the Milky Way are similar to our Sun, this suggests there could be billions of potentially habitable Earth-like planets within our galaxy alone. Kepler's mission wasn't solely focused on finding potentially habitable planets. In fact, the majority of its discoveries were strange and exotic worlds that are not suitable for life, but are still fascinating. Among these are gas giants, planets primarily composed of hydrogen and helium, with a small rocky core also known as hot Jupiters. These planets orbit very close to their parent stars and are abundant in Kepler's findings. One particularly intriguing gas giant is KOI 5AB. Astronomers first identified KOI 5AB as a possible planet in 2009, making it only the second planet discovered by Kepler at the time. However, this elusive world was overlooked for a decade due to the immense volume of data Kepler produced and the complexity of its star system. KOI 5A, the planet's host star, has a companion star, making the analysis difficult. By 2014, researchers determined that the KOI 5 system actually contains 3 stars, further complicating matters. It wasn't clear if KOI 5AB truly existed or if the signal detected in 2009 came from one of the companion stars. However, with additional data from the TESS satellite, scientists were finally able to confirm the existence of KOI 5AB. Finding a planet with a stable orbit in a multi-star system is rare, and this discovery could provide important insights into planetary formation. Kepler also uncovered a variety of other exoplanet types, including super-Earths, which are more massive than Earth but lighter than Neptune and Uranus, made of gas, rock, or a combination of both. Then there are lava planets, super-dense worlds larger than Earth that orbit close to their stars, some of which, known as Chthonian planets, may be the remnants of evaporated hot Jupiters. Additionally, Kepler hinted at the existence of Trojan planets, which could be found in unusual locations or as companions to larger planets, though none have been definitively identified yet. Kepler's mission officially ended on October 30, 2018, when the telescope ran out of fuel. It was deactivated after receiving a good night command from Mission Control, coinciding with the 338th anniversary of the death of the astronomer Johannes Kepler, after whom the telescope was named. Despite no longer being operational, Kepler's discoveries set the stage for future exploration. With upcoming telescopes, like the James Webb Space Telescope scheduled for launch in 2021, astronomers will be able to take a closer look at some of the exoplanet identified by Kepler, bringing us closer to answering the age-old question, are we alone in the universe? What do you think? Could there be even more strange worlds hidden in Kepler's data? Let us know your thoughts in the comments below.